Hey everyone, so I'll walk you through how to build a network-aware CI/CD pipeline with GitLab and Ansible. So before we continue, you need to read the article version of this video. It would instruct you on how to use multipass to create an Ubuntu VM with Docker pre-installed, configure passwordless SSH from VS Code into the VM, install Container Lab on the VM, and deploy a router. Install Ansible on the VM, build and push an Ansible Docker image, deploy a GitLab container and sign in, and within the GitLab container, create a repository, configure a Linux runner and Docker executor. And lastly, configure Git credentials and clone the repository. So the first task we're going to do is create a GitLab pipeline variable. Now, while we're doing this, our Ansible control node, which is the Docker container, needs to know the router before it actually connects to it. And how would he actually know the router? He needs to have the router's host key saved, within its default SSH directory. And to actually do that, we can manually get the router's host key using the SSH key scan command. That is, if we execute it within the Linux VM. Then when we get the router's host key, we can copy it and create a host key variable on GitLab. Then the Ansible container can run an echo command within our GitLab pipeline script. So we're going to define an echo command within the GitLab pipeline script. Then when the pipeline script is executed, it now knows the router, so it can run any Ansible playbook we define, the pre-check and co. So yeah. Okay, now I'm getting the router's SSH host key. I'll now navigate to my repository. And go to settings, specifically CI/CD settings. Then I will create a new variable. And uncheck protected variable because we are not creating a protected branch. Yeah. It almost looks like the protected variable flag was checked again. Alright, we're good. Alright, so in this next stage, we are going to be creating a GitLab job script. So I'll be creating the job script inside the Container Lab project repository. So let me just close this terminal here. And yeah, you can see that job script has been created. Alright, so let's go over the stages. So we have the pre-check, the deploy, the post-check, and the rollback stage. Now the next thing is the image. This image is the Ansible image, basically a container. And each of the playbook will run inside this container. This localhost 5000 is the container registry, which has been deployed. And we can confirm that here by running docker ps. And this is the container registry. Next thing is the before script. So the variable we initially created in GitLab, we are saving the variable inside this SSH directory. Now, Ansible needs to connect to the router in order to configure it. And for it to configure it, like we've discussed previously, it needs to know the router, and the host key to the router is saved here. The next thing is the pre-check. We're defining the actual pre-check job here now. The pre-check job is using the pre-check stage. Tags here is referencing the Linux runner. So the Linux runner will start the job, and this means it needs to be referenced, so the Linux trust will start the job and assign the job to the Docker executor and said, okay, Docker executor from this job. And that job contains the script, which will be the pre-check script. This is inside the repository. Now, this role is saying that only run this job when there is a merge request event. So it would be when a merge request is opened. So the next stage is the deploy stage. We are applying the deploy playbook, and this playbook is configuring a new interface. But while configuring the interface, it mistakenly brings down the critical interface. The rule is saying run this job when you've merged your merge request, and it still has the same tags, with the other jobs. The next stage is the post check, and this is applying the pre check playbook because the post check and the pre check are doing the same thing. They are checking if the critical interface is still up, and this particular job is going to fail because this playbook we previously applied mistakenly brought down the critical interface. And this stage will run when you've merged your merge request, meaning because when you merge your merge request, it's merging to the main branch. The rollback is applying the rollback playbook and it's running when a job fails. So when on failure, and this on failure is referencing when any job fails. So when the post check fails, the rollback will apply the rollback playbook, which will configure the critical interface to configure the IP address and bring the interface up. And the role is also applying when you've merged your merge request. So yeah. Okay, so let's create the Ansible playbooks. When you're creating your Ansible playbook, you need credentials to the router or switch or router in this sense. And to do that, I'm creating a variable. So this variable, has the router's username, password, and the router's IP address. Now, the next thing I'm going to create is, the inventory file. Okay, now let me start creating, the actual playbook. So I'll start with the pre-check. Okay, so this is the pre-check. Is gathering all interface, printing it out, and then it's failing if the critical interface is down. So how does it actually do this? So it loops over all the interfaces. With the interface, it produces like a list of dictionaries. Each list represents a particular interface. So within each index of the list, you would see like key value pairs. For example, enabled. Enabled could be true or false. But here we're checking when enabled is false and when the name of the interface is Ethernet 01. So we're targeting this interface. If this interface is false, which means if this interface is down, fail the job and output a message saying the interface name is down. All right. Let me create the deploy playbook now. So this is configuring a new interface, which is Ethernet 02. The previous one we created was Ethernet 01, but we are simulating a failure here. On Ansible, when you're configuring an interface, you need to bring it up, just like your regular network devices. So instead of us bringing the interface up, we are configuring the interface to be down. So we're shutting down the interface just to simulate a failure, and we're shutting down this particular interface. That's what this deploy is doing. So the post check is still using the pre-check because it's doing the same thing. It's checking if that critical interface is still up, and if the interface is up, it will pass. If it's down, which this failure here we defined, if it's down, this failure would trigger. Now, when the interface is down, what are we going to do? We'll implement a rollback. So let me create the rollback playbook. So this is our rollback. Our rollback is reconfiguring the interface. So it's just configuring this interface and outputting the results. Yeah, that's all. All right. So to configure the critical interface, I need to create a virtual environment using UV. So I'm installing UV right now. Now UV is installed, I can now initialize UV, create the virtual environment and activate it. Great. Now I can add Ansible and the Ansible pylib library. Okay. So now I can create the critical interface. Remember, I'm using rollback, which is configuring the interface. So as we can see now, under the after, the critical interface has been enabled to true, and this is the critical interface. If you still want to verify that the interface is up in your device, you can SSH into the device. So I'm SSH into the router right now. Okay, so let me check the interface. So 10.01, you see, has been configured and the interface is up. Alright, so let me create a git ignore file. But first of all, let me deactivate this virtual environment. Alright. This git ignore file is making sure that when we are pushing our changes to GitLab, it doesn't include anything that relates to UV because it's not even required. So it's not required because our Ansible container was not installed using a virtual environment. It was installed as a system package, and we can confirm that here in the Docker file. So you can see that we use apt install, to install the things related to Ansible and the actual Ansible package. We did not have to create a virtual environment. So that's why we are ignoring the UV related files. So yeah. Okay, now we're going to add all our files to the repository. So this command is adding all the files, adding a commit message, and pushing it to the upstream remote repository. Okay, so now everything has been added. A new branch has been created upstream. So let me navigate to the repository to confirm. Okay, now we are in GitLab. So I'll navigate to the repository. We can see now that there are two branches here, and we can confirm that here. So we see the new branch patch. Click on it. These are all the files we've created. Now I can open a merge request. New merge request. Select the source branch, which is the patch. The target branch is main. Continue. Leave all these things as they are and just create the merge request. Okay, so we can see now that the pre-check job has automatically triggered. Let's wait for the job to complete. Okay, so the pre-check job has passed. I can click on the pipeline and go to the pre-check job. So let's see the commands. Okay, job succeeded, and we see a few Ansible outputs. Let's just verify. Now we can see that the before script, it echoed the variable into this directory. So Ansible knows the router. Now Ansible has executed the playbook and it passed. So that means the critical interface is still up. Now let's go and merge the merge requests. Okay, let's merge. Immediately merged, you notice that a new pipeline has started running. This pipeline has the deploy job, which is running right now, the post check job, and the rollback job. Let's wait for the pipelines to complete. Okay, the deploy job passed, it ran successfully. So this is a new interface we are configuring. But in that interface, we simulated a failure where we brought down the critical interface mistakenly. So it's an assumed simulated failure. Since we brought down the critical interface mistakenly, the post check failed because the post check is checking if the interface is up. So since it failed, the rollback kicked in. You see it's passed. So let's go and let's see the commands. Let's visit the deploy job. So we see a few Ansible outputs. So again, the same before script passing the variable and the playbook, the deploy playbook successfully configured a wrong interface. And we can see the wrong interface it's configured here. After this is the interface, it mistakenly brought down a critical interface. This critical interface, it brought it down. See, enabled is false. Enabled is supposed to be true. Previously, which was before, enabled was true. After, enabled is false. So this was a mistake. Now let's verify the other job. This is the post check. So you see, this job failed. So why did it fail? So enabled false. That's why the job failed. And enabled is supposed to be true. You can see that it actually ran the pre-check. Now let's go and verify the last job. Rollback, which is fixing the issue. So the job succeeded. You see a bunch of outputs. Same thing with the before script, passing it, running the rollback logic. Let's see what it did. Before, the critical interface was false, so the rollback fixed it. After, critical interface is now true. So as you can see here, the job passed. Yeah, that's it. We can also log into the device through SSH to verify. We can see that our critical interface is still up. This is our critical interface. The new interface we configured is down because we're supposed to bring this one up. We went to go and disable this interface. So if you want to bring this interface up again, then you just have to modify your deploy scripts and fix the issue. Where's the issue now? Make this one true and target the correct interface and push it. We're not doing that here, but you get the logic of what a pre-check, a deploy and a push check and rollback does. Yeah. So if you are adding more logic to your pipeline, you can have a particular playbook that will, contain any configuration you're making. But now, if you want to target specific critical resources or critical parts of your device, like maybe an interface or a protocol, you can individually configure those things in your pre-check, and your post-check also, and your rollback too. So in regards to Ansible. So yeah.